Hi, welcome back. Today we're going to cover another fundamental distribution type, and this one is radial distribution. So if I crank up the number of instances, it forms a ring. You can change the radius of the ring. You can calculate the orientation for these cubes here. You can affect the angle. And then you can also push it into space. So if you wanted to create some kind of spiral, you could do that as well. So I'll show you how to create that type today. It's actually fairly simple. So we're going to start by copying our previous linear distribution emitter. I'll just make a copy of that. I will rename it. So here we have our linear distribution. We don't need that, so we'll get rid of it. And we will create a new module. Just call it Patreon radial dist. Quickly set the flags before I forget and wire it up. And we're ready to go. So we want to calculate the position on a sphere, or sorry, a circle. So we will have to write out the particle position. And I will just grab my existing maps. So this is a simple one here. Just grab the emitter number of instances, and this is our user interface for our radial distribution with the calculate rotation and angle. So the first thing we want to do is calculate theta, the actual angle. And the way we do that is we take our angle and we divide it by the number of instances. So if we have an angle of 360 and we have 10 instances, we're going to split our pi up into 10 equal parts. So that'll give us this fractional number here. And then what we want to do is we want to calculate, well, what slice of the pi are we? And the way to do that is to take the particle index and then calculate my slice offset. So take this fractional pi, multiply by my index, and that'll give me my offset. Once I have that, we need to calculate cos and sine, which I will lovingly call A and B. So we take this offset here. We'll go degrees to radians before we pump it into sine and cosine. Now you could have probably just wired it straight in. Sine has a one that takes a degree, but whatever. Okay, so we have our unit circle here, and basically what we want to do then is multiply it by the radius here. So we'll take it, and this will size by radius. We will make a vector, and this vector we're going to make, when we're thinking about it, and from what I've shown you, is we were rotating around the x-axis or the YZ plane. So for this, we're going to just basically wire in x directly and then use these values to calculate y and z. And one of the things we want to do here is use our distance x here. So we want to factor in pushing this radial distribution into space. So it's really simple again. We just, whatever the user has for x to create that spiral type effect, just multiply my current offset down that spiral and wire it straight into the x. Now to do the y and z, I'll just quickly paste this for y and z, wire them up. Oops, this should be y and this should be x. Sorry, and this is z. So once again, x goes straight in, and then y, what we will do is we'll simply add it to our sign, and this will add distance y to that value. Quick copy and paste. Let's do z. And that should be it. If I could connect my wires, yay. Compile, apply, save. Hey, look at that. So let's just quickly test it out before we add the last piece, which would be the rotation. So angle. Oh, let me pause it first so we can see it in real time here. Cool. Distance. Cool. X, Y, Z, good, and radius, cool. Okay, so the last piece is also quite simple, is the calculate orientation, which is a Boolean. So we'll take it and put it up over here maybe. If this toggle is on, we want to set the particle's mesh orientation. So that's a quaternion, so we're going to need a couple. And if it's not true, just output an empty value. And if it is true, I want to take the execution index again, and I want to multiply it by theta here. Get my offset. And then from that, simple Euler to quaternion. And because we're going along the YZ plane, we'll want to affect the roll. So if you decide to add more planes, maybe you want to, as a convenience, calculate them on different planes and have some setting for that in the user interface, you'll have to wire in yaw and pitch accordingly. So where did it go? Compile for rebuilds. Oh, there it is. Okay, good. Turn it off and it disappears. So give y a 1 value and we're good to go. Cool. So on and off. Great. Okay, so that's pretty much it. I will be covering, I don't know, I've got a spherical distribution type, and then we can start, enhancing these more. Doing some animation and making copies of things is another thing I want to do. So you have one instance of this radial distribution type. Well, what if you have 10? What does that lead to? That leads to tunnel-like effects. So if I had this spiral here and I bumped up the number of instances, maybe changed the radius, and then if I made duplicates of this, I could have a tunnel that I could fly through. Yeah. So if you like the tutorials and you're watching this on Vimeo or YouTube and would like to see more, please consider donating to my Patreon. The link is in the description. And for those who do support me already, thank you very much. More tutorials are coming very soon. Thank you. Bye-bye.